Good morning, dear students. Welcome back to our online classes. Now, we were doing chemical reactions, chapter 6, and we have already learned through our previous classes the different types of chemical reactions based on their chemical compositions, how the reactants they make different types of products based on whether they are combined directly, whether they undergo decomposition, whether they make their products by displacing the lower elements in the activity series by higher metals of the activity series, or either by the interchange of ions. So based on all these factors, we have already learned that there are 4 different types of chemical reactions, and they are combination reactions, decomposition reactions, displacement reactions, and double displacement reactions. We also learn the 2 types of double displacement reactions. They are precipitation reactions and neutralization reactions. Now today, in our today's class or today's session, we are going to learn 2 different types of reactions based on heat energy involved. Now, based on heat energy involved, we can also classify chemical reactions into different types. Now, what are those different types of chemical reactions? With some examples, and we'll try to understand how one particular reaction can be given one name of reactions, one type of reaction, and how or why we call certain types of reactions the another type of reactions based on heat energy. Based on heat energy involved in any particular given chemical reactions, we can categorize any given chemical reactions into 2 types. The chemical reaction in which heat energy is absorbed. Absorbed means taken in. We have to provide heat to the particular reaction. Such type of reactions are called endothermic. Endothermic means heat, endo means absorbed, taken in. So whenever there are chemical reactions in which heat energy is or are absorbed, those type of chemical reactions are called endothermic reactions. The other type of chemical reactions are exothermic reactions, and the chemical reactions in which heat energy is evolved or given out, or heat energy is produced during a chemical reaction, then such type of chemical reactions are called exothermic reactions. I'll repeat this once again, boys. The chemical reaction in which heat energy is absorbed are called endothermic reactions. Absorbed means heat energy is taken in. Whereas the chemical reactions in which heat energy is evolved means given out or produced, are called exothermic reactions. Let us try to understand these 2 types of reactions. They are endothermic reactions and exothermic reactions in a little more detail. Now I have drawn over here 2 circles, and let us imagine that the larger outer circle is our environment or the surroundings, and the inner smaller circle is our system or where the reaction is taking place, where there are reactants, and these reactants they react with each other. So we'll take 2 things in consideration in order to understand endothermic reactions as well as exothermic reactions with the help of heat energy. So remember, the outer larger circle is our surrounding or the environment, and the inner circle is the system or reactants, and these reactants react with each other. Let us try to understand these reactions with simple but one of the most important substance that we use in our everyday life. Correct, that is water. We all know that water exists in three different states. They are solid ice, liquid water, and steam or water vapor. Now let's go to the first condition. Let's say we have steam with us and we want to convert this steam into liquid water, and again finally we want to convert this liquid water back to its solid form, that is ice, solid ice. Now we all know that if we see the temperature, steam is the steam has the highest temperature, whereas ice has the lowest temperature. Now can we change steam to liquid water and then liquid water back to ice? Yes, we can do that. Now let us see, while the interchange of these different physical states of water, how heat energy is related and how heat flows from one particular state to another state. Now let us first see steam. Now just imagine, what will you do in order to convert steam back to liquid water? What will you do? Will you heat it, or will you take out heat from steam? Correct. We'll take out we'll take out heat energy from steam. That means we have to take out heat from steam like this. We have to remove heat. So when we remove heat energy from steam, then steam will convert to liquid water. So if you see over here, so if we take water as the system, let's take water as system, that means the reactant, water as the system, and let's take surrounding. This is our surrounding outside the steam. Now from system, heat is flowing outward. So from the system, heat is flowing outward. Okay, I hope I have made this point clear. If this thing happens, if heat is flown out of the steam, then it changes back to liquid water. Now let us again try to change liquid water back to solid ice. What are you going to do again? Again you are going to take out heat from liquid water. So that means we again have to take out heat energy from water, liquid water. That process is called condensation. So when we take out heat energy from liquid water, now that liquid water will change back to solid ice. So if you see over here also, what is the direction of flow of heat energy? If you take water as system, so from the system, heat is being flowing out to the surrounding. Okay boys, so in both cases, while converting steam to liquid water and converting liquid water back to ice, in both the cases, heat energy is flowing out of the system to the environment, and that is why this different state there is a different change in different states of matter. So this type of reactions in which heat energy is given out from the system, so here heat is being given out from the system, heat is being given out from the system to the surrounding. Okay, so heat is produced, the surroundings will become little warm, whereas the system, the reactant, the product will become cold. That's why ice is cold, because from water all the heat energy is being taken out, and what is left, the ice which is left is with very less heat energy. That's why we say ice is cold. So these type of reactions, can you now tell me which type of reaction is this? Heat is given out from the system to the surrounding, heat is given out. That means heat is produced, evolved. So what type of reaction is this then? Correct. This is exothermic reaction. So this is exothermic reaction. So this is exothermic reaction. Why it is exothermic reaction? Because heat is being produced or evolved from the system to the surrounding. Another chemical reaction, this is a physical reaction. Why? Because there is only change in the states of matter. Now let's go to a chemical reaction. A chemical reaction, let's take example of calcium oxide. So when we add water to calcium oxide, that process is called dissolution of calcium oxide or quicklime. So when we add calcium oxide water to calcium oxide, then calcium hydroxide will be produced, which is also called slakelime, along with heat energy. That's why when we add water to calcium oxide, the container becomes hot. Why? Because this is what type of reaction? Exothermic reaction. Why it is exothermic reaction? Because heat is produced, or heat is from this reaction, heat is given out, produced, evolved. So this type of reaction in which heat energy is evolved or produced is called exothermic reaction. Now again, let's take the same example, water, and let's again take three different states of water: solid ice, liquid water, and steam. Now if we want to change solid ice to liquid water, what do we have to do? Correct, we have to heat ice. If we are heating ice, then what are we actually doing? We are providing heat energy. We are giving heat energy to the ice. We are giving heat energy from outside, and that heat energy can be of any form. It can be, the heat energy can be from sun, the heat energy can be from fire, the heat energy can be even light energy. So when we provide heat energy, when we give heat energy to solid ice, with that heat energy, solid ice changes to liquid water. So now again, let us try to understand this particular process with the help of heat, surrounding and system, and heat involved. So surrounding, this is the surrounding, the larger circle, and system is the solid ice. So from surrounding, we are providing heat to the system. So system heat from the surrounding, system is taking heat energy, absorbing heat energy. Let's again move to liquid water now. Now if you want to change liquid water to steam, what do you have to do? Correct, again we have to heat liquid water. Heat liquid water means we have to provide heat energy from external source, that is surrounding. So after getting heat energy from the surrounding in the form of sunlight, in the form of solar energy, in the form of thermal energy, electrical energy, whatever form of energy we can provide over here. So when heat energy is added to this liquid water, it changes to steam. So if we see over here, water is the system and the environment is our surrounding. So from the surrounding, heat is being absorbed by the system, which over here is water. So now we already learned that the reactions in which heat energy is absorbed is known as, correct, endothermic reaction. So this is what type of reaction? Endothermic reactions. Endothermic reactions. I'll once again repeat this. In this change of states of water from solid to liquid and to steam, in every step we have to provide heat energy. For example, we have to provide heat energy to solid ice, then only it will change to liquid water. Again, if we provide heat energy to liquid water, then it changes to steam or water vapor. So in this, but these changes from the system, from the surrounding, heat energy is being absorbed. So this type of reactions are called endothermic reactions. Let us take one chemical reaction. Nitrogen combines with oxygen, not at ordinary temperature. It needs a lot of heat energy, and heat energy involved over here is creates a temperature of 3000 degree Celsius. That means it is a huge amount of energy to produce nitric oxide. Okay, so this happens naturally in our environment during lightning. So nitrogen in the air and oxygen, they are both present in our atmosphere. So these two, they get a chance to combine to form nitric oxide during lightning, because when there is lightning produces huge amount of heat energy, and with that heat energy, these two gases, they combine together to form nitric oxide. So remember, the atmosphere is over here, in that is, I'm talking about the nitrogen fixation. So when nitrogen combines with oxygen in the atmosphere, in the air during lightning, so lightning is the external source surrounding. So lightning provides heat energy to the system. This two makes the system. So when heat energy is absorbed by these two reactants, they produce nitric oxide. So here heat energy is absorbed. So this type of reaction is called endothermic reaction. So once again, I'll revise it to you. Based on the direction of flow of heat energy, all chemical reactions are classified into two types. They are endothermic reactions and exothermic reactions. Endothermic reactions are those reactions in which heat energy is absorbed, whereas exothermic reactions are those reactions in which heat energy is evolved. This much for today's class, boys. I suggest you to refer to your book for more examples. There are lots of examples given in your book. I suggest you to see each and every examples and also learn the chemical equations. Stay safe and do all things well.